Docker is a platform designed to simplify the creation, deployment, and running of applications using containers. Containers are lightweight, portable environments that ensure software runs consistently across different environments. Unlike virtual machines, containers share the host system's operating system, making them more efficient, faster to start, and easier to scale. Docker's architecture includes several key components. The Docker client is the command line interface that users interact with, sending commands to the Docker daemon, which runs on the host machine. The Docker daemon is responsible for building, running, and managing containers. Docker images are the blueprints for containers, containing the application code, system libraries, and settings. When you run an image, it becomes a container, which is an instance of the image running as an isolated process. Docker Hub is a cloud-based registry service where Docker images are stored and shared. A typical workflow using Docker starts with building an image. This is done by creating a Dockerfile, a text file with instructions on how to build the image, such as specifying a base image, copying application files, installing dependencies, and defining a startup command. Once the image is built, you run it using the "docker run" command, which creates a container. Containers can run in the foreground or background and can be set to restart automatically. Managing containers involves starting, stopping, viewing logs, and executing commands inside them. Containers can be removed when no longer needed. There are several basic Docker commands. "Docker pull image", downloads an image from Docker Hub. "Docker build name", builds an image from a Docker file in the current directory and tags it with a name. "Docker run image", runs a container from a specified image. "Docker ps", lists running containers. "Docker stop container", stops a running container. And "Docker container", removes a stopped container. Docker is particularly useful in several scenarios. In microservices architecture, each microservice can run in its container, making the system modular and easier to manage. In continuous integration and continuous deployment (CI/CD) pipelines, Docker provides consistent environments for testing and deployment, reducing the issue of discrepancies between development and production environments. Docker also simplifies scalability, as containers can be easily started, stopped, or replicated to handle varying loads. In conclusion, Docker transforms the way applications are developed, shipped, and run by using containerization to ensure consistency, portability, and efficiency. It is an essential tool in modern software development, particularly for rapid deployment and scalable environments. By adopting Docker, developers can focus more on coding and less on managing infrastructure differences.